Okay folks, here's try number 2. Hopefully this works a little bit better. Today we're going to look at factoring trinomials where a isn't equal to 1. So all day yesterday we had our a value was equal to 1. So today we're looking when it's not 1 and it's not a common factor that can be taken out of everything. So I'm going to skip all of this part. I'm going to cut to the chase a little bit in this one. I'm going to get into this like little quick method, which I'm just going to call it the line method. And it's just super simple to find these solutions. There's just a little bit of a trick that goes to it. This one talks about factoring again and guess and check by guess and check. Yeah, we're not going to use the guess and check. We're just going to do the line method. So hopefully this audio is a little bit better, and if not, just go online, watch the video, kind of watch what's the process that's going on, and then also check out the PDF, and hopefully from that you'll get it. Okay, so when we have an a value, yesterday, or let's go recap from yesterday, we had to multiply to this number and add to this one. So that's what we did yesterday. But that was when we didn't have an a value though. So with today, what we're going to do is we're going to look at it has to multiply to this number and then add to this one. I know it seems a little bit confusing right now, but we'll get that cleaned up here. I'm going to write the question out again. So we have 3x squared minus 5x minus 2. So whenever we have this case, we have to multiply our a value and our c value. So we're going to get 3 times minus 2 to give us negative 6. So now we consider this to be the multiplied number, the number that we have to multiply to get. And then we have minus 5. Let me just switch colors here. Our minus 5. This is the value that we want to add towards. So again, we can create our table. I think everyone's comfortable with the table, and so we're going to kind of stick with that one. So we're going to go multiply. Well, in order to multiply to minus 6, we've got minus 1, 6, plus 1, minus 6, minus 2, plus 3, or 2 and minus 3. So looking at the additions of those, we've got 5 minus 5, plus 1 minus 1. So since we're after minus 5, we noticed it's this one. So what we're going to do is we are going to write those two values out. So here's the line trick. So we draw the lines, we draw 2 lines. Below those, we write each of our 2 factors. So plus 1 and minus 6. On top, so on the tops of those lines, we're going to take, since we had a 3x squared, what we're going to do is we're going to take the 3x squared, we're going to put it on top, but we're not going to write it as 3x squared. We're only going to write on 3x. And then again, these are taken from the 3x squared. But then we drop, oops, not dorp. We drop the square. So it just becomes 3x. Once we have these conditions, we look at how can we factor anything out, or can we cancel anything out. So let me see what color I have, and I use green. I can't do anything with the 3x and the plus 1, but with the 3x and the 6, I can take out a 3. So if I take out a 3 from the top and the bottom, I'm going to be left with a 2 down below. Okay, so just to show you what I mean, if I have 3x minus 6, I can change this to 3 times x over 3 times minus 2. And then I got a 3 over 3 that cancels. I'm left only with x minus 2. So then my two factors, I have 3x over plus 1 and x minus 2. And that is our answer. We just set that up as our two brackets. 3x plus 1 and x minus 2. And we're at done deal Donnie. So again, we can check our answers by substituting a value in. In this case, we will. I just want to find out what original equation. So we have, so let's do a quick check. Our two equations were x squared minus 3x squared, sorry, minus 5x minus 2. And we're going to check if that is equal to 3x plus 1 times x minus 2. So I'm just going to use the point at 1, at x equaling 1. So we're going to get 3 times 1 squared minus 5 times 1 minus 2 to get 3 minus 5 minus 2 to get minus 4. On the right hand side, we were going to get 3 times 1 plus 1 and 1 minus 2. We're going to get 3 times minus 1, which something isn't right. Oh, 3 plus 1 is 4. That's why. 3 plus 1 is 4. Times minus 1 is equal to minus 4. So therefore, left side equals the right side. And we're good. So just to kind of recap, we started off with, we have to multiply our first number, a, x squared, so the a from the ax squared, and the c, so the very last number. And then that's the new number you have to consider as the two numbers that multiply by. Then we have to look at adding to that middle number still. So then we go through our combinations just like we did before, found out that it's 1 and minus 6. So we write our two lines, line, put the plus 1 and the minus 6 on the bottom. Then on top of those, we take whatever our a value was, our ax squared, so in this case 3x squared, and we put them on top, but we get rid of the square. So it's just 3x and 3x. Then we look at reducing the fractions wherever we can. So on the first one, the 3x plus 1, we can't reduce anything. But 3x over minus 6, we can reduce the number. We can take a factor of 3 from each, the numerator and the denominator, to give us x minus 2. So again, going over that process, I factor the 3 from each of those to show that it's x and minus 2. So then those are our answers, 3x plus 1 and x minus 2. Did a quick check, left side equal right side. Okay, so I want you to give it a try on this question. Again, pause the video, do the question, come back, and look at the answer. So going forward with this, I have to multiply my 2 and my 14, so that gives me 28. So this is the number I need to multiply by, and I need to be able to add to 11. Well, going through my combinations, we've got 1 and 28 minus 1 minus 28, 2 and 14 minus 2 minus 14, 3 doesn't work, 4 works, 4 and 7, and minus 4 minus 7, and that will be it. After we do that, we'll flip back to getting the correct, the same results from the other side. So we're going to add these together. We're going to get 29 minus 29, 16 minus 16, 11 and minus 11, and yes, I realize that that should be a 7, and we were looking at trying to get 11, so there's our answer. Excuse me. So we draw our line, we put our two values, 4 and, oh gosh, not 4 and 4, but 4 and 7. 4 and 7, and again, those come from here, and on top, we take our value, we had 2r squared, so we're going to put just 2r. Now we look at reducing. Well, the 2r and the 4, we have a common factor of 2. So I'm going to factor 2 from my r and 2 times 2 to give me the 4. And notice I can cancel off these 2's. So I'm left with just r over 2. 2r over 7, nothing I can reduce there. So then that's all it is. My answer is r plus 2 times 2r plus 7. Okay, so just again doing a quick check. I'm just going to leave this answer here at 2r squared plus 11r. Again, I'm going to check at 1. So we're going to get 3 times 9, which gives me 27. Here I'm going to get 2 plus 11 plus 14, which is equal to 28. Oh, 27, sorry. 27. Okay, so again, left side equals right side. We're good. So, another example. So I'll let you, again, pause the video, go through it. You know that you get the drill. Okay, so we need to multiply our first and last value to give us 6, and that's our new multiply. Then we have 5 as our add. So we've got 1 and 6, negative 1, negative 6, 2 and 3, negative 2, negative 3. And those are all our factors. So then we're going to look at adding these. Oops, not clear. We've got 7 minus 7, 5 minus 5. We were after 5. So there's our answer. We are going to use the line method, put our 2 and our 3. And we started off with a 2n squared, so that means we will have a 2n on top. Once we have that 2n on top, we look for factoring. We have 2n over 2, which means we will have a common factor of 2 on each of these. When I factor the 2 out from the bottom, I'm just left with 1. So I can cancel off the 2's. 2n plus 3 can't do anything with, and I have my answer. n plus 1 and 2n plus 3. And again, you can go forward and check this answer. Okay, another question. Again, pause it, do the question, come back, watch the video. So we need to multiply our 5 and our 8, to give me good old 40. And that's our new multiply. So this is going to be a little bit bad in the sense that we're going to have a lot of numbers now. And it has to add to 13. All right. Now for the big table. We have 1 and 40 minus 1 minus 40. 2 and 20 minus 2 minus 20. 3 doesn't work. 4 will work. 4, 10 minus 4 minus 10. 5 works, so 5 and 8 and minus 5 minus 8. 6 doesn't work, 7 doesn't work, and then it goes back into 8. So we've got all our factors, wasn't all that bad, and now we're going to do the additions. We got 41 minus 41, 22 minus 22, 14 minus 14, 13 and minus 13. We were looking for excuse me, we were looking for 13, positive 13, so we've got 5 and 8. So again, line, 5 here, 8 here, and we've got 5b squared, so it'll be just 5b on the top. And we look at where we can factor. Well, we got 5b over 5, which will be 5 times b over 5 times 1. We can get rid of the 5's. to leave us with just b plus 1. 5b plus 8, can't factor that, so you're going to be just left with b plus 1 times 5b plus 8. And again, you can check yours using a value. Okay, I'm going to let you go ahead and do this one. I'll come back. Actually, I'll just do it. So we've got 3 times 16, which is 48. Okay, I'm going to skip forward a little bit. Multiplies to 48, adds to 22. So I'm going to say that it is... Oh, this should be minus 48, sorry. Multiplies to minus 48, adds to 22, so it'll be 24 and minus 2. So we've got positive 24 minus 2. You can go through your table and find those values, and then I'm going to write my 3x above. I can pull a 3 from each of these, leaving me with x over 8 and 3x minus 2. So our answer is x plus 8, 3x minus 2. You can go back and check using the method. Okay. Excuse me. Another method, which I'm going to show you, just so you have two options. This one makes a little bit more sense algebraically, and kind of you can see why we do things a certain way. Similar idea, just it's not like a little trick, it's a little bit more work. So more work, but you understand the meaning of it then. Okay, same approach. We start by multiplying our two values, so we get a 24, and that's going to be our multiply. And then the next one is add to 11, just like before. So we're going to go through our factors. Excuse me. So we have 1 and 24, minus 1, minus 24. We've got 2 and 12, minus 2, minus 12. We've got 3 and 8, minus 3, minus 8. We've got 4 and 6, minus 4, minus 6. And that's all she wrote. So going through the additions, 25 minus 25, 14 minus 14, 11 minus 11. We were trying to get 11. I don't have to go any further. Okay, so what we're going to do now is we're going to take that 11x. So because this equals 11, we're going to change it so it's 3 plus 8. So I'm going to rewrite my equation as, what was it? 2x squared. I'm going to leave the plus 12. But now where it was, it used to be plus 11x. I'm now going to split it into 3x and 8x. So 3x plus 8x still equals 11x. So I didn't change the question. And now we're going to do factor by grouping. So notice if I take the 2x, oh, this should be 2x squared. 2x squared and the 8x, I have something in common there. So I've got a 2x that I can take out of each. And from 3x plus 12, there's something common there as well. So from the first one, I'm going to take out a 2x. I'm left with x plus 4. And from the second one, I'm going to take out a I'm just going to take out 3, and I'm left with x plus 4. Notice I have x plus 4 for both of those, so that's the common factor again. So I have x plus 4 multiplied by 2x plus 3. So again, a little more steps, and then you have to do a factor by grouping. So a lot of kids kind of prefer the line method, but this kind of shows you all the steps. So some of the more academically driven kids will prefer this method versus that line method. So another example. So multiplying to these two, giving us 24, adding to minus 5. So going through all the questions again, all the options. So, sorry, this should be a minus 24. And it is a big difference. Excuse me. So we've got 1 and 24, negative 1, sorry, and 1 and minus 24. We've got 2 and minus 12, minus 2 and 12. We've got 3 and negative 8, and negative 3 and 8, and 4 minus 6, and minus 4, 6. So now we got to find all the adds of these. We've got 23 minus 23, minus 10 plus 10, minus 5 plus 5. Oh, we wanted a minus 5, so our answer is here. So we start by rewriting our equation. We leave the first and last terms the same, so we have our 2x squared and our minus 12. But what used to be a minus 5x, we are going to change into plus 3x minus 8x. And this question actually turns out to be very similar to the question we had just done. So I'm going to put the 2x squared and the 8x together and leave the 3x and the minus 12 together. So from the first one, I'm going to pull out a 2x. I'm left with x minus 4. From the second one, I pull out a 3, and I'm left with x minus 4. Again, the x minus 4 is common, and it's left by 2x plus 3. Just as a bit of a side-by-side comparison, doing the line method, we found the numbers to be 3 and minus 8. So this is just another way we can check it. We've got 3 and minus 8. 3 minus 8. It was 2x squared, so 2x on top, 2x on top. Notice I can't factor here. I can factor a 2 out from that one, so I'm going to be left with 2x plus 3 times, oops, not 2x, times x minus 4. And we get the same answer. Okay, so another question, and I'll let you use either method. So you can use any method that you want. I'll do this one with just the line method, just because, so this video doesn't turn out to be an hour long. So we've got to multiply these two. You get a minus 20 and add to give us 8. So at this point, you probably are getting a little bit better about trying to think about all these factors, but if not, just write them out. So minus 1, 20, 1 minus 20, 2 minus 10, minus 2, 10, 4 minus 5, minus 4, 5. Adding them up, I get 19 minus 19, minus 8 plus 8, minus 1 plus 1, and we were after a positive 8. So line method, line, oops, minus 2 and 10, and we started off with 5n, so 5n squared, so we're going to have 5 n's on the top. The first one cannot be factored at all, but from the second one there's a common factor of 5. So we can pull out our 5 from each of those, and again I'll go through the steps on that one. 5 times 2, the 5's cancel. So our final solution is going to be 5n minus 2 times n plus 2. And done deal Donnie. Okay, there's another question here. You can go forward and find the solution to it. I'm going to go ahead and look at this question here just so we can get through it. Very similar approach, but what we're going to look at first is sometimes you can remove a common factor. So this is like we did before. We're going to remove a common factor, and then we're going to be left with smaller numbers, so we don't have to deal with such large numbers when we do our multiplications and figuring out which two terms multiply to this and add to that. So what's common to each one of these? Well, our last number is a 4, so the biggest thing we could take out is a 4. Can we take 4 out of the 10? No, we can't. Well, we can, but then we're left with fractions. We know that's not possible. So what we want to do is look at the next thing would be 2. So can we factor 2 from each of these? Yes, we can, because they're all even numbers. So if we factor a 2 out, we're left with 5x squared minus 11x plus 2. At this point, this is just a trinomial where a is bigger than 1. So this is just looking at that line method. Okay, so same approach as before, multiplies to 10 and adds to minus 11. Going through our factors, multiplying, we've got 1 and 10 minus 1 minus 10. You've probably caught on that it's this one already, but if not, 2 and 5 minus 2 minus 5, and those are all our options. So looking at the additions, we've got 11 minus 11, 7 minus 7. We are trying to get minus 11, so there's our answer there. So we're going to do our line, so we got minus 1 and minus 10. Now, we're looking at putting at the a value in, or the a squared. We have to look at what we had from our trinomial, not the 2 times that. That answer, we just leave the 2 out front and we just bring that in the end, just like from yesterday. So we are going to put a 5x here and a 5x here. By doing so, notice we can't reduce anything here, but here we can reduce that 5. So we're going to have a 5 times x over 5 times minus 2. 5's cancel, and we're left with a final answer, 5x minus 1 times x minus 2. So the line method is the easier of the two, but that distribution method, or the factor by grouping method, where you take that one value, split it into its 2 pieces, and then do factor by grouping, makes more sense algebraically. Like, it's not just like, oh, you just do this little trick, and you get the same answer both ways. So this isn't quite our final answer, because we still have that 2 that we have to consider. So that 2 just goes down in front. So that will be our final solution. Same thing as yesterday, factoring with 2 variables. We know the trick again is just putting the y on the last variables. So we're going to look, do we factor any numbers out? Well, 4 and 6 are even, but 5 isn't, so we can't factor 2 out. So we're just looking at multiplying to minus 24 and adding to minus 5. I'm going to skip forward and know that it's minus 8. Whoa, that's not a straight line. Minus 8 and plus 3. Negative 8 and plus 3. I'm going to use the line method. And on top, I'm going to put our 4x. I can reduce this one. So I'm going to get x minus 2 and 4x 3. So then my answer is going to be x minus 2 times 4x plus 3. But we need to bring in the y's again. So I should have left some more space. 4x minus 2y. Let's do different colors. 4x minus 2, 4x plus 3. And we put in our y's on the end. And that's it. So again, we kind of work on some of the stuff we worked from yesterday with just that little change of doing the line method, which turns out to be not too bad. Okay, so some of the key concepts. Use guess and check. Yeah, don't use guess and check. Just call it the line method. Or breaking up that middle term. Don't worry about guess and check. Again, but you still have to list all possible factors. If you're doing that line method, you should just determine what two numbers multiply to this one and add to this one. So it's kind of looking up same way as this, where we look at if you have A and C, you have to make the product of A and C. So you multiply the first one and the last one, and that's the value, that's the multiply. So product meaning multiply, and then the sum still being the add value. So it has to add to the B. And then factor by grouping is we split them up into those two numbers that we just found by doing that multiplication, and then using a common factor by grouping. Oops. So for your homework, I'll put an online worksheet, and I'll also try and put the physical worksheet in the classroom, and it should be located on the desk as well. It'll be called, I don't know if it'll actually have the name, but there'll be a worksheet there, and you'll see there'll a bunch of trinomials, possibly. If not, it'll be online anyway. Okay, folks. So that's the lesson. Hopefully the audio is better, and we'll take it from after the break. So I hope you have a great Easter and have a good break. Bye bye.